Everybody, welcome back. This week is going to be our week 12 from April 21st through April 27th. This week we're going to finish all the lectures. We're going to finish Unit 4 with radical functions. Okay, so here you have the radical function lecture, the PowerPoint with all the animations, some support material for radical functions. Check your understanding if you want to make some exercises. Question forum if you have any question for this week. The discussion question and the quiz number 9. Those are going to be the last discussion question and the last quiz. Then we will have the study guide for the exam number 4 and the unit for review, because next week we're going to have the exam number 4 using Respondus Lockdown Browser, as you already know. Okay, and then after that week, we're going to have the final exam. The final exam is going to be in Pecos campus, remember, in person in Pecos campus, Monday 5th from 9 a.m. to 10:50 in Agave room 1440, 1240. For that exam, you can create and use a page of notes with no examples, back and front, and you can also use your phone Desmos in your phone in a test mode, or you can use your laptop. Sorry if you hear some noise. Okay, and as I said before, this week we're going to cover the radical functions. We're going to cover domain and range, solving radical equations. Okay, so for example, here you will have square root of a negative number. Remember, negative number is not a real number. Therefore, the domain of this function would be all real numbers for x such that g of x, what is the radicand, what we're going to have inside the radical, we're going to call it radicand, should be greater than or equal 0. Okay? So for example, here we have the square root of 2x minus 10. In order to find the domain and range, you can graph. Okay, if you graph this function, you're going to have this rate function here. And you can notice that the domain, which means all the possible value in the input, are going to start in 5. I'm going to move through all the rest of the domain to positive infinity. That means that my domain in this function would be all real values greater than or equal 5, because we have 5 here. 2 times 5 is 10, minus 10 is 0, square root of 0 is a possible value, which is 0. And the range is going to start, you can see from here, from 0, all the possible values from 0 to positive infinity. So that means y would be greater than or equal 0. That would be my range. Also, you can find the domain algebraically. So remember the radicand, in this case 2x minus 10, when we have an even root, square root, fourth root, sixth root, should be greater than or equal 0. So in this case, 2x minus 10 greater than or equal 0, you can treat this like an equation. So we could say 2x greater than 10, x is greater than or equal 5. Okay, so that will be my domain and my range, all the possible values in the output. Okay, that would be from y from 0 to positive infinity. In this case, it's going to be the same. Okay, so the domain of this function, if you graph, you're going to have this blue function. It's going to start in negative 2. Okay, so my domain would be x greater than or equal negative 2, and the range all the possible values in the output for an even root. Okay, then you will have more examples. Also, we're going to learn how to solve equations with one radical expression like this one over here. And we also going to learn how to solve equation with more than one radical. Okay, and you can also learn how to solve it not only algebraically but graphically. Okay, and then look the last one. Look this one. If you solve this equation, okay, so the first step, you have to isolate the radical term. So positive 5 is going to be negative 5, then square both sides, and my solution would be 22, x equal 22. But you have to check all the solutions. And if you plug 22 here, you're going to have square root of 22 plus 3 is going to be square root of 25. That would be 5. And 5 plus 5 is equal 0? No. So something happened here. This is what we're going to call a strange solution. So you will have to solve any radical equation and then check if the value is going to be a strange solution or not. Also, we're going to have some real-world examples, and that's everything we're going to have in radical functions. So if you have any question about radical functions, please let me know as soon as, or any question, please let me know as soon as possible. Have a nice week.